want to say thank you to everybody for joining us. Looking forward to this session, this webinar by GBF, Antenna Innovations, the Next Generation. We've got a great panel with us, so I'm going to go ahead and get us started. These are our distinguished panelists. I will let everybody here give a brief introduction of themselves and their company, and then we'll launch into a discussion about antennas in the ground segment for satellite connectivity. I'll start with just a very brief intro for myself. My name is Caleb Henry. I'm the Director of Research at Quilty Analytics. We're a research and advisory firm focused exclusively on the satellite and space industry. Prior to that, I spent several years as a journalist writing especially about satellite communications as well as the broader space sector. So with that, I will turn it over and let our panelists introduce themselves in the order that they are presented here, and then we will go into our discussion.
Thanks, Caleb. Ryan Stevenson, I'm the Chief Scientist at Kymeta Corporation. Kymeta, over the last 10 years, has commercialized the novel metamaterials technology that we use for electronically scanned arrays. We're on to our second generation product now in a variety of different variants of that product. And I'm really excited to be here. Thanks for the invitation.
All right, Lucas.
Okay, yeah, Lucas Nystrom. Thanks for having me. So I'm the CTO at SatCube. SatCube is a company based in Sweden. We design, produce, and sell terminals for broadband connectivity over satellites. The current terminal offerings that we have are for GEO, but we are currently working on a new range of GEO and LEO, and in some cases multi-orbit terminals to be launched.
All right, Gavin.
Good afternoon, everyone, and thank you for having me. I'm Gavin Cox. I'm the R&D Engineering Manager at Global Infocom. Global Infocom are a designer and manufacturer of antenna terminal solutions that include both reflectors and transceivers and all of the associated components that would allow a full system to be put together.
All right, and Todd.
Hi, my name is Todd Brown. I am the Director of Business Development at ABL Technologies here in beautiful Asheville, North Carolina. We've been in business for almost 30 years next year. We mostly produce VSAT antennas for the government, which has been our market for the last 20 years. We started out with the owner, Jim Oliver, like I said, almost 30 years ago in the S&G market, and have shifted over the last 20 years. So glad to be here.
All right, so thank you everybody for introducing yourselves. I want to start the conversation just by talking about what's new with each of your companies. I feel like there's a lot of focus these days on new antennas. We certainly saw at the satellite show. The headline announcement was not a launch, but actually a new antenna being rolled out. So let's start with some of the new products. I think Lucas might be good to start with you because you mentioned that your company focuses on the GEO market, but you're expanding to multi-orbit and to new types of features that you're seeking to enable.
Yeah, so the background that we come from is that the core team has done terminals for the last 25 years or so, and over this course we have learned a number of challenges and some learnings that we now see that we can bridge those into the LEO domain. I'd say that there are two interesting projects ongoing. One is a vehicle-mounted multi-orbit LEO plus GEO terminal, and then there's another one which is a pure LEO terminal for a fixed broadband installation, which would then serve either as a primary connection to rural areas where there is no coverage today, or as a resiliency backup connection for critical infrastructure, which would then be in urban environments.
All right, who is next, Ryan?
Yeah, thanks, Caleb. So Kymeta at the SAT show this year, we launched our terminal with OneWeb for their LEO constellation. We've historically been targeted GEO, but now that the LEOs are coming, we've had a great interaction with OneWeb and launched that terminal together with them at the SAT show. So we have our suite of geo-based products, both commercial and military, and those are all variants of our next generation antenna technology that we launched in November of 2020, based on a liquid crystal switching technology. And we've had a commercial version of that and a military version of that called the Osprey that we launched last year at the SAT show, and now the Leo version. We will have a Geo-Leo interoperable product coming out towards the end of this year. And you know, for us, it's as our volumes ramp, our innovation now is more around driving aggressively down a cost curve to ramp into commercial markets, while we pursue a strategy with the military as well, which is more of a feature-rich, heavily ruggedized type of approach to give them flexibility to operate across LEO, GEO, and other networks.
All right, thank you. Todd?
Yeah, thanks, Caleb. We've been focusing on basically our core types of terminals lately. We've been trying to get more into the XY positioner for our terminals, which would allow our customers to have both LEO, GEO, and MEO. And since we work more in the parabolic realm, that's allowed us to be able to do band switching. So, you know, we're hearing the same thing everybody else is: multi-orbit, multiple frequency bands. So that's one of the big concentrations we've been doing to satisfy our government customers. As we see those requirements coming out, we're also trying to update our older terminals that they have thousands of in the field to give them more MEO geo capabilities on those, on the as over L tracking systems. So we're looking at updating our older systems to give them more capabilities, and then moving in the future with our XY positioners.
All right, and then Gavin?
So at Satellite this year, Global were showing a small terminal that is cost and performance competitive, that will be suited to both LEO, MEO, or LEO, MEO applications, based on parabolic antenna, but with some of the software that we have developed to support that terminal, it would allow multiple terminals to be used as part of a small cluster, so that we could do seamless handovers, and also start aggregating the throughputs as well.
All right. So I think the theme that I've heard from everybody here is multi-orbit. Everybody sounds like they're trying to transition to products that will enable people to use satellites from various different systems, various different orbits, you know, perhaps even at the same time. I'd love to hear from panelists what all is involved in making an antenna system capable of supporting multi-orbit. What are some of the challenges that you have to address, and how are you doing that?
Yeah, Caleb, I can maybe start that one off. You know, for an electronically scanned flat panel, you know, there's some things that you have to do. You have to be able to be polarization agile. The LEOs in the KU band now are circularly polarized. Switching over to a GEO, you have to be able to switch your polarization in the antenna to linear polarization, and then in particular for Cometa being mobile on GEO, you have to track on that linear polarization, and then you also have to track the LEOs as well. So you need a fast scanning capability. For us and for a lot of the other ESAs that are out there, we're able to do a break before make handoff, because you can switch your beam over fast enough, you know, to switch over to a LEO, or switch between a LEO and a GEO. And that's something we've been demonstrating in mobile environments actually since 2021. So those are a couple of the challenges for our technology. We're able to do that polarization agility very power efficiently compared to other phased array technologies. And for us, as we're working on, you know, very size, weight, and power constrained mobile platforms, power consumption is really a key issue.
Yeah, Caleb, this is Todd. I think from our perspective, it's a lot of the same things that Ryan was just talking about, right? when you're talking about the lower orbits, it doesn't matter with your what the antenna type is, right? The challenges are still there. It is trying to figure out how to track the various constellations and how they're best allowing you to track those. Is it an open? Is it a closed loop? What are you doing that? How fast are you able to respond to that? To keep locked on the constellations. That's something that we've been working on a lot here in our control systems. We've been updating our control systems, which is a pretty big challenge, as you move forward and you keep on taking the lines that you've had for such a long time in a geo realm and trying to get them into MEO, which we were very successful, with O3B, and now we're moving that into mPower, and now moving down to the LEOs. It's all about the tracking, right? And the efficiencies that you can get while you're doing that. So that's probably one of our biggest challenges, and you're probably going to see that across a lot of the terminals in the industry.
I think, just to echo that again, tracking is obviously, it's faster at LEO speeds, but as a parabolic antenna manufacturer, we would be doing a make before break with 2 apertures. So it's the handover speeds as well. With some of the constellations nowadays, the time between handovers isn't very long, so you can't just do it with a single aperture without having significant breaks in connectivity.
I'd like to add to what Ryan was saying here about the polarization agility, which in the Ka band space, where you have the same frequency bands and the same polarization, which makes it a bit easier, because then you can basically determine the size of your aperture based on the geo link budget, and then if it works on geo, it's also going to work on LEO. Whereas on the Ku band case, you need to be able to do this switching, which is a bit unfortunate. It makes it a bit more difficult to design. But then even if you solve the polarization and the sort of the RF domain, you still come down to the fact that the different networks, they tend to use different waveforms, and they tend to use different modems. So that you need to be able to solve it after your mixing stages, or in some stages you even need to change your transceivers, which makes for a difficult practical problem. Although you've solved the RF link, you need to design the system to be compatible with both.
Yeah, if I can add on there just a little bit, modems and transceivers. Right now I think we're looking at just general industry wide, not really elegant ways of doing that, and I think as things become a little bit more software defined, a little bit more standardized and interoperable at the user terminal level, we'll see more elegant solutions for working with different waveforms and that kind of thing. That's something that we're looking forward to.
Yeah, so I get the sense there are 2 themes that emerged from that answer. One was this difficulty with standardization and dealing with polarization. The other is actually tackling non-geosynchronous orbits using, I think a lot of the emphasis has been on flat panel electronically steered arrays, but there's also new approaches that are being pursued with parabolics. So maybe let's tackle that one first, and then go into the standards discussion. When it comes to creating antennas that can support MEO or LEO using parabolic dishes, that has typically been looked at by the industry, at least especially for the consumer market, but even more broadly, as something that has been too costly, and it becomes cost prohibitive for customers to make use of. So for our panelists that are developing antennas that are going to use 2 or more dishes, what are you doing to keep the cost down and to make that an accessible solution for whether it's rural customers like Lucas mentioned, or even enterprise sites that want to make use of satellite connectivity?
Yeah, I could then maybe start off here. So our approach on the LEO domain is to use mechanically steered flat panels, or any actually other types of passive antennas as well. And the driver here is, of course, you need to get motors that are sufficiently robust to sustain for several years of continuous operation. And to get back to your question on how do you do this in a cost-efficient way, and the answer is sort of that you need to cut weight and you need to cut power wherever you can, and you have to be very careful in how you do your thermal analysis, because what starts to degrade your motor performance over time is if it has excessive torque and excessive strain, mechanical strain over time, and if it overheats and if it draws too much power. And that becomes a very difficult problem, of course, because you need to get a very stable system, but it can't really weigh anything, because if it weighs something, then your motors are going to suffer. So working on weight reduction techniques are critical.
And I think from Global's point of view as well, from our heritage of coming from a DTH background and moving into VSAT and then onwards from there, we come at the design from a very sort of price performance competitive point of view. So it's easy to add cost into a low cost design. It's harder to take cost out of a top end design in some ways. So I think that we are quite well positioned there. And as Lucas has said, things like motor choice and ways of actually moving the antenna that mean that we are able to manufacture it in a cost-effective way is vital. So, looking at methods of manufacture that aren't one-off machine or aren't machining, but maybe castings, pressings, and all of the traditional sort of techniques that you would see in some of the lower cost terminals that we can bring into motorization architectures.
Yeah, I would say, and then continuing down that line of thought, as we're talking about multiple terminals being required at gateways, that now the number increases as you come down in the orbit, right? That's going to drive up numbers, right? So economy of scale is something else when you're designing a parabolic system that, traditionally you weren't maybe selling the higher volume, but in the LEO realm, the necessity for multiple terminals to do, make before break. But not only that, gateway terminals, et cetera, can help because the economy of scale drive the price down when you're thinking about going to suppliers for, these more efficient motors, the castings, et cetera. So that's one thing that we've been taking advantage of.
All right, great. I don't want to leave Ryan out of the, even though we were talking mainly about parabolics. So Ryan, what can you share about Kymeta's own effort to bring costs down with a flat panel antenna?
Yeah, and I think it's interesting. I think every panelist in every question that they've answered so far has said the word cost. So obviously that's front of mind for everybody, and especially in light of the sort of disruption that we've seen in the industry from Starlink principally and Kuiper coming along. And so for us, we approached cost from the fundamental technology. I mentioned earlier on that we've commercialized a pretty novel technology, very unique in the industry, this diffractive metasurface technology. We aligned our engineering and science with the flat panel display industry, and that was our approach to how we were going to scale at consumer electronic kind of volumes. So the current technology uses liquid crystal as a switching mechanism, and the way that our essential beamforming element is manufactured comes off of display manufacturing lines, same as the crystal televisions that you see in the electronics store. And for some of the other components, we'll have a more traditional looking transceiver at the back of the antenna and modems and those kinds of things. That's where as volumes increase, we're working with industry partners and really generally, if I can give a message across the whole industry, we need the industry to pivot into thinking about much higher volumes. And then we see some folks that are making that pivot and starting to realign their engineering and their manufacturing towards higher volumes, and some folks that aren't. And I'm just speaking broadly, but for us, especially for some of the other stuff that goes into our terminal, we're starting to see that movement, in block up converters, waveguide diplexers, low noise block down converters, and some of these components. Um, we need the whole industry to start thinking more generally about high volume and low cost.
So I'm gonna just press you on that a little bit. When you say high volume, what are you talking about? Because the cheapest by cost and I think by price antennas right now are the ones that are being put forward by Starlink and Kuiper, priced in the hundreds of dollars. It's kind of the same as a PS5 for the gamers out there.
Well, we need to think about the markets too, right? So in a lot of that price range is typically fixed residential. I mentioned for mobile applications, and Chimeta generally is focused on mobile applications, although our OneWeb terminal launch initially would be for fixed applications, enterprise fixed applications. Mobility engenders higher levels of environmental ruggedization, just inherently, temperature swings, shock, vibration. And when you focus on more industrial applications, even Starlink's terminals you see are more expensive in those categories, right? They need to be ruggedized to that level. And so we're not talking about the few $100 kind of terminal, but we are talking about volumes in the tens to hundreds of thousands, even for those industrial applications, professional vehicle type applications, other enterprise level mobility applications. And so we need to generally get the industry thinking more about those kinds of volumes, not hundreds a year, but hundreds of thousands a year.
Just on your manufacturing, Ryan, you say that, well, I know you're using some of the LCD production lines. Are you still seeing costs falling on LCD panels, or has it sort of flattened out as the TV markets sort of get saturated and there isn't anywhere else to go for the panel manufacturers? Are you there yet?
No, we're not there yet, and it's largely volume driven. So one way that we look at that is sort of the endpoint is something called open cell TFT, and LCD screens have essentially become commoditized for the display market, and that's volume based, right? So if we were shipping 100 million panels a year, we'd be at that open cell TFT commodity price. So there's still room there for us in our technology, and as we can scale down our volume curve to continue to drop cost.
And again, just picking up on something I'd read back in, I think it's Microwave Journal back in 2021. I think there was discussion about whether you were looking at some of the LED Varactor technologies as well. So I don't know if that's still under active consideration for cost reduction.
It is actually, and just recently we've published some work at IEEE Phase Array Conference last October, and just recently at European Conference on Antennas and Propagation. Our Ka band design, which we have been demonstrating, will leverage more of a solid state diode based approach. This is a Varactor diode, so it's a microwave diode, but it looks very much like what the display industry is doing in mini LED. And so again, aligning ourselves to the display manufacturing technologies where they've invested so heavily in making these approaches scalable for very high volumes.
All right, so I'm going to use this chance to remind our audience that you can also ask questions. You can send questions to us, and we'll see them, and I'll get a chance to ask those to our panelists here. Gavin, you're my inspiration to remind the audience that this is a discussion, this is an open conversation, and we want people to ask as many questions as they would like, and we'll seek to get to them throughout the course of this webinar. So with that, let's pivot a little bit to kind of a discussion about interoperability and standards. I think this came up as a previously mentioned pain point. So I guess the first question, how many panelists here are members of the Digital Intermediate Frequency Interoperability Consortium? It's a mouthful.
Show of hands. We're strong proponents. Chimeta was one of the founding board members of DIFI. We're we're very strong proponents of what Diffie's about and what Diffie's trying to do, because it will really transform the user terminal and ultimately help reduce cost.
Yeah, ABL, we knew that as we move forward, we would have to do it. So we've teamed with other members within the Diffie Coalition. You've probably seen some of the releases that ABL, Wavestream, Data Systems, some government partners. We actually put them on the terminal. Being a parabolic, it's pretty easy to take those digital components, the first prototypes, get them out there, and then get them over the air to prove that not only is the concept there, but it can be proven, it can be shown to end customers. So we went out there, we did that. We were able to go from a more digitized terminal to an analog one, do 20 megabits throughput from an analog to a digital and then back to the analog. So it's not just coming up with the standards. I think it's getting out there and putting the practice out there and seeing how we can apply these and then see where the holes are in that standard, and then things that can be added to that standard. So I think we've already talked about this, right? We're kind of, you've got a variation of different terminals here. You've got some flat panels, you've got some ESAs, you've got a couple of parabolic makers here. We each give you a tool in a toolbox, but those standards will help us do what Ryan was talking about, which is come down to commonality of parts, right? The more we can do that, the more we can standardize these various terminals, the more the experience will be there. And that's what Diffie is driving to. That's why it's so important, right? It'll give that user experience. It'll take all these different architectures, all these different types of terminals, and give what we're really all aiming for, which is the user experience. I think, it doesn't matter about the terminal. It doesn't matter about the constellation. It matters about what the person on the end is experiencing and how are they experiencing that, and how can they shift, from, like a cell phone architecture where you're shifting from server to server to service. How do we make that real? It's Diffie. It's standards like that. It's so that everyone has the same experience.
I mean, Global aren't currently members, but we are working with partners who are. So, we'll be ready to implement and put the technology into the terminals as and when we need to. But as you say, it is user experience. So the user shouldn't care which modem it is or anything like that. It should be a single cable plug and play, and it's just seamless to the end user.
Yeah, Lucas, did you want to comment on this?
I think, my view here is of course the same as the others, that the terminal is just a means to an end. The user, to be frank, they don't care. They want internet, and then we do a lot of work into the terminal, but then in the end it's something for they to get connected. So any type of standardization would be very beneficial.
And I think recently I think that idea of standardization has met a little bit of resistance. Historically, the satellite communications industry has been very siloed, and it's just taking some effort to kind of break through that. At Satellite Show this year, there was the demonstration with iDirect and Gilat. We're seeing DoD RFIs come out now that are requesting information on the Diffie standard and how vendors are going to be using that standard in their solutions. And so, we're starting to see some change in the industry towards standardization, which it's going to benefit everybody. Sort of taking a lesson from this industry. It has to move that way. It just has to.
Yeah, and I think once critical mass is reached, then it will just open the floodgates and everything will go that way. But it's just building that critical mass, showing that, and demonstrating that it does work, does do what it needs to do.
And to add on this, you Ryan, showing your phone here, it's the recent releases in the 3GPP standards for 5G is a step in the right direction, that the telecom community is now looking towards space more and more, and we should try to push for this, because there's a lot of learnings that we can get from the telecom sector, because they have reached these volumes that all of us want to reach. and the price point is where it needs to be, and the power consumption of the units is also where it needs to be. So instead of trying to reinvent everything with our own sort of space standards, I think that we should try to converge with this terrestrial side as much as possible.
Yeah, and terrestrials had interoperability for years, so yeah, I think there is definitely a lesson to be learned there.
Yeah, what 3GPP is doing, release 17 with the NTN standards and waveform, Kymeta is very excited about that too. You know, we've seen a couple of different flavors. We've seen 5G backhaul, where you sort of go to DVB S2X and you transport data to a 5G either user equipment in the field. We recently did some work with Fraunhofer on a pre-release version of release 17 NTN to host the NTN waveform natively, which I think is ultimately where things are going to head. You're going to have a native environment that bridges across these different networks, whether it's geo, LEO, terrestrial. Kymeta right now in our product, we enclose an LTE radio and router with the satellite modem, and through an SD-WAN orchestrated through the cloud, you'll have two concurrent links that you can fail over between one or the other. But we call it the hybrid terminal, and it's very hybrid. It's not native, but ultimately you can think about that extending forward into if you had one common protocol that would manage the air interface and the connectivity between all these different networks. I think that's ultimately where we're going to be. And I think ultimately where we have to be, because whatever projection you look at for how much data will be consumed in the future, it's scary, and it means you need every network available to handle it. Not just what is available in your current location.
All right. So we're getting a decent number of questions in from our audience now. So I'm going to start running through those. First, a clarification. Someone asked if I referenced Starlink terminals being $200 each. I said a few hundred FPW. That was the PlayStation 5 reference, which is at last check around $500. And no, I'm not on a waiting list, but I have followed. I have followed that sector. So last check that I saw, Starlink was $500 to $600 price per terminal, and their cost at last check publicly, I think, was $1,300 to build. So still selling them at a loss. And SpaceX only provides updates on that on their own schedule. So who knows what they actually cost to make today. But anyway, a clarification there. Now going into some of the other questions, an attendee asked, wanted to go back to the subject of multi-orbit switching. And they asked, how do you keep latency optimized when switching from lower to higher orbits?
Well, but let me try that one on. If you switch from LEO to GEO, your latency changes dramatically, and that's just the way it is. You're going to go from a 40-ish millisecond kind of latency to a 500 to 600 millisecond latency. I mean, right now, in the way that that's done across different modems, the modems pick that up. Kymeta's LEO GEO switching between a GEO modem and a LEO modem. And I think the trick is then to be able to interleave that on the back so that you're not necessarily losing or dropping a session. The way that Kymeta does that right now is, through an SD-WAN implementation. And so when we do that between, I mentioned a cellular side and a terrestrial cellular side and satcom side, there's a big change in latency there, but you don't drop the session because it's all orchestrated through the SD-WAN.
All right. Any other takers on that one?
Got it, the question.
Nope. All right. We will move on. Another question. This is about Starlink and Kuiper. Starlink and Kuiper terminals are receiving a lot of media buzz. Can you separate the hype and comment on what impresses you about their terminals and what you would expect some of the more established ground segment manufacturers do in terms of improvement for their LEO terminals?
Caleb, if I could jump on that one, it's a really good question. And it really speaks to, I think, what we've been talking a lot about here, which is cost. The thing that impresses me most about Kuiper and Starlink is their systems engineering, and they've been able to leverage their advantage of being vertically integrated and engineer the entire end-to-end link to cost optimize the user terminal. And that's a very different paradigm than satcoms historically, which has been, the satellite operators launching very large, expensive satellites and then trying to monetize that asset as much as they can. From the user terminal perspective, that drives some pretty draconian requirements down to the user terminal that make it very expensive. And therefore, you see the low adoption. And so I think there's a couple of things. I'd like the industry to start changing their mindset. And we hear a lot that we, as an electrically scanned flat panel, we have scan loss, we have these other issues. So we get categorized with traditional SSOs as a disadvantaged terminal in some cases. I think we need to change that thinking. We need to change that thinking into a cost optimized terminal and get the SSOs to start thinking more about how they collaborate with companies like Kymeta on the user terminal side to approach something that looks a lot more like that vertical integration that we see from Starlink and Kuiper.
I think, again, just echoing that, you sort of see the teardown videos of the terminals and things like that on YouTube, and they look to be nicely engineered and well put together. So I mean that's really as an engineer is nice to see. But I think that what will impress me most is that for those people in the UK, they'll see a Starlink terminal and it'll be like a satellite dish that's used for Sky TV here. It won't be, there's an antenna or a dish. It'll be there's a Starlink system or a Sky dish. I think it will just take over the market like that, and it'll be like the Hoover versus the vacuum. I think it will go that way. So it's some very good sort of marketing going on, I think, somewhere. But again, I think as sort of Ryan said, the ability that Starlink have got to manage the entire vertical is useful. And certainly when we've been looking at terminals for our customers, the ability to get in early, have influence on the link budgets, so we can look at losses. Again, it might be that we can be slightly more lossy in some areas, and that's it can be optimized elsewhere, and it's just a balancing act to actually try and get the lowest cost solution with visibility of the whole system architecture available to you.
Yeah, if I can add to this, so I completely agree with the view that one of the key reasons why the terminals are so impressive, and they really are very impressive, and the system level is also very impressive because it is a system level design. It's not we launch something to space and then hopefully someone on the ground solves the user terminal side. And if you look at the release from Kuiper and you look at the smallest terminals, which are the size of maybe not one smartphone, but two. So it's a very small panel, and yet you're able to get good speeds through it, which speaks volume, because it means that a lot of the link budget has sort of been shifted into space so that the terminal on the ground can be a lot more simple. So then you can have much higher volumes of user, which is then recouped on the satellite side because they can sell more capacity. So this having a network which is designed to operate on these small, like 5 by 5 inches terminals, as opposed to a 70 centimeter parabolic, which has been or maybe even larger, which the geos are typically designed for, is a big advantage when you're trying to design the ground side.
All right, we are cruising through questions, which is great. Just another reminder for our audience, we've got about 20 more minutes on the webinar, so if you have questions, keep sending them in. I'm going to interject one of my questions because Lucas made me think about it, which is this whole notion that Starlink and Kuiper thought about the antenna in the process of creating their satellites. So it was a full kind of an end-to-end design, as opposed to, like you said, building the satellite and then letting the antenna guys figure that part of it out later. Are you seeing satellite operators whose names aren't Starlink or Kuiper doing better at planning for user terminals in their system design, from the very beginning, or is it still more of the same?
From Kymeta's, I'm sorry, go ahead.
Yeah.
From Kymeta's perspective, it's a little bit of a mix. We're starting to engage in conversations now where Starlink's really been a wake-up call to some of the more traditional SSOs, and we're starting to have those conversations. But then we still see some instances where it's more of a, here, we issued an RFI, please respond, and in some cases we don't, because the requirements are such that we don't think we can build an economical terminal. So I think right now it's a little bit mixed, and there's some more SSOs on the leading edge of that see the opportunity, and there's some that haven't gotten it quite yet.
Yeah, no, I was just going to say along the same lines as Ryan, but in our business, we're seeing a lot of forward-thinking SSOs have approached us. In fact, it's a major part of our product development right now. That's led that, right. Finding a lot of partnerships, because I think traditionally the conversation has been here all day long. It's got to be the solution of the terminal provider after the network's up there, and I think as Starlink came out and kind of forced the issue of don't put it up and then they will come. We've been approached by a number of partners who have come to us and said, hey, we need at least this in the beginning, right? We need a minimal amount of offering. We need gateways, we need, etc. Can you help us? So I think the dynamic has definitely shifted from what I saw 25 years ago, when you would get something up and then you would, have to be qualifying, figuring it out, and they would already be on orbit for a year. And so I think it's nice to see that Starlink has pushed that, but I do think it has definitely shifted from what I've seen, what we've experienced at ABL.
Yeah, and our experience also mirrors that we'll get a mixture of RFIs, and we'll get a sort of working with some of the newer satellite operators or people who are planning launches at the early stage, to look at what may be possible. And I think that's got to be encouraged, and I think it will happen more as other companies launch their own constellations, that they won't necessarily have the experience to cover all of the vertical as some of the larger operators would. So they will need to be going out much earlier to find out what is state of the possible with terminals, and build that into their planning as they're seeking investment, etc.
Okay, shifting to another question. One attendee asks, how do you see the current political environment with Asia as a route to lower cost manufacturing will impact product developments, lowering costs? I assume that's related to the situation in Taiwan. Anybody want to take a step at that one?
For us, there's kind of an issue that arises from this. We're mostly from the government, so this is a very political question for us, because as the government starts to switch in its focus, right, it's looking for a more near peer environment, and they're starting to exercise a lot of requirements in your supply chain, right? So that becomes very critical on that front for people who are delivering products to the government in the end, right? So as you start looking at Asia, as the tools in the toolboxes grow, you have cheaper terminals, more purpose-built terminals. Gavin's kind of talked about this. Depending on what your system is going to do will depend on how that is reflected in cost, right? But the problem is, as terminal price goes down, you need to look for other markets for supply chain in order to bring down the price but remain the quality. But that becomes an issue as the government is releasing more and more RFIs and saying we want a supply chain management that ensures, stability, but yet where your parts are coming from, and they won't be under scrutiny, in the long run. So it's very political for some companies that are getting out there into the government markets now that that rely on that, but try to be price conscious.
Yeah, if I would add on to what Todd was saying there about price, we see, given the shifts in the industry, DoD is also expecting lower costs or lower price, and that forces you into a situation where you've got to consider Asian-based supply chains. For us, we have a bifurcated product strategy. We have a very strong commercial terminal design, and that's all about cost optimization. We also have the military ruggedized, very feature-rich design, and for us it means establishing a sort of backup supply chain. If critical components that we can source, from trusted areas, that does add cost, into the military version of the product. But it's a tough one, like you're saying, Todd.
Yeah, they see a $1,300 terminal and they think every
Right.
terminal should be $1,300.
Right.
But then you can't get rugged. You can't get the parts that you really should be. Let's just be honest, right? Giving to the quality to the soldier that's in the field that relies on this, not just for communications, but for life, right? Let's just be honest. And when you do that, cost rises. It has to, right, to get the right product that they need. So yeah, it's very challenging right now on both ends of that spectrum.
If I can add here, so SatCube strategy from the start has always been to do in-house production. So we do production in Sweden, and we try to source most components from Europe. And this obviously drives cost, but it only drives significant cost in low volume, because once you go up in volumes and you can do automation and building robotized stations, then it's no longer the labor that drives cost. It's basically the electricity bill and the machines, which you can then have amortized. You amortize it over the years. So you can have cost efficient manufacturing outside of Asia if you get the volumes. The components that are difficult are the semiconductors, which Europe at least is very much not on it. It's all Asian, or a lot is from Taiwan. So Europe is trying to pick up their pace with the Chip Act, but it's going to take a while. So when it comes to the active components, it's going to be very difficult.
Yeah, Global as a company has manufacturing on, I think, 3 continents, and global supply chain for sourcing of equipment and components. But again, we are looking, and some of the developments that we're doing in-house are working with European foundries, etc., to evaluate chips and PAs and some of the more specialist components to make sure that we have alternatives available should we need to change our existing suppliers. So it's an ongoing process, and I think as a company you've got to be out there evaluating and looking at the options all the time anyway, just to make sure that you are getting the best, what price, and also it is competitive for what you want to be doing.
Your question to throw out, and maybe I'll split this actually in half. One half for our European colleagues here, and one half for our American colleagues. There are 2 military satellite systems that are being developed. The Space Development Agency in the U.S. is very close to launching their first satellites for the proliferated warfighter space architecture, which will have Ka-band connectivity. And then over in Europe, there's the IRIS-2, IRIS-2, program, which I think is still more so in its infancy, but is being contemplated as a multi-orbit GEO, MEO, LEO network for sovereign connectivity in Europe. The sense that I've gotten is that at least on the US side, there's not much of a focus that, or there's been a delayed focus on the ground segment. In other words, they're not following the Starlink Kuiper model of thinking about it as an integrated network, but are playing catch up on the ground segment side. So what is your advice as antennas in or experts in user terminals and antennas to prospective government customers that are deploying new systems, very expensive new systems that they want to see used, but so far have not really engaged the ground segment on?
Well, Caleb, I think I differentiate the ground segment into user segment and gateways. I think the gateways are in the Ka band, and the user segment is in L band. So at least on the satellites that SDA is sourcing, they'll have L band phased arrays on them to serve Link 16 specifically, and that's not a frequency band really where Kymeta plays in our technology, this metamaterials technology. X, KU, KA, higher, this is where we go. So I would hope that SDA from the user link or user segment perspective would start to consider more traditional, commercial SATCOM bands like KU, KA in their user links. I think focusing on L band at first to serve Link 16, that's going to kind of limit.
Yeah, and this was something that we did in the initial panel discussion, was had we been approached by them, I know that ABL hasn't, we, just because of the inherent capability of parabolics, we're able to go from L to Q right now, but we didn't do anything really with them. However, from a personal standpoint, having worked for the government for 25 years, and help them develop terminals and implement technologies, I'm going to agree with Ryan. They need to learn from not their past experience, but what people are doing now. The government is very much a past experience, but that's changed. I only left a couple of years ago, and things were starting to change within the government mindset. And I think this is probably going to be one of those first exercises, and really should be, where they look to the commercial segment to see where they can, copy that model from a beginning to end solution, kind of like a Starlink, maybe not as, intricate as that, because as we've discussed, everything was built in a specific vertical, which made it very efficient, but as much as that they can copy, because when they do that, then they're going to have a better user experience. And that's what it's all about. I think we all agree here that it's the user experience. It's not the terminal. It's not the architecture. And one thing that they've got to do, which they typically don't do very well, is get to the end user and understand the requirements, not the wants, but the requirements, and really boil those down. And then look at what else that can do to move into the future. So there are a lot of units nowadays who use up converters from UHF into L band, right? And then use their voice networks over that, because UHF satellites have never been replaced because the government didn't anticipate that. They anticipated MUOS would do that. So I think this constellation has more things that it can do than probably what they're looking at. So they need to future-proof it too.
Okay. From the European side for Iris Squared, it was actually, I think, running in parallel to this. There was a webinar on Iris Squared today, presented, I think, by the European Union, but we've got both physical representation at the meeting in Belgium, and also online representation at that. So we will be trying to engage and push the point that early engagement with the manufacturers of the terminals is a good thing to be doing. So yeah, we're trying to advocate, certainly on our behalf there, but I would think just generally as well for the ground segment industry.
All right, and Lucas, any thoughts?
Not really. I can just concur, and I agree with everything that's been said before, that we for this to be a cost efficient system, we need to start considering that it is a full system. It's not a space segment and a ground segment. It's a broadband connection.
Mhm. All right. To move back into the Q&A, just one thing with so I'm gonna have to follow up, Ryan. And I think that the SDA network, from a graphic that I've seen, they actually want to do the Link 16 L band, Ka band, and believe it or not, optical downlinks to into theaters of war. They're pretty. They keep those cards pretty close to the chest, so just have to try to see if there's any clarity on that. But my understanding is that they will be trying to do all three, with Link 16 being the most mature.
Yeah, no,
Uh,
I mean, opticals definitely. There was a lot of discussion around that in the satellite show this year. Optical crosslinks, optical downlinks. I mean, that's not really new. Way back, TSAT was considering optical crosslinks. So I mean, there's certainly a lot of challenges, especially when you're thinking about optical downlinks. And Weather is a huge factor. If you're trying for high availability, you essentially you can't have any cloud cover. You can't, that's a really tough one.
yeah, certainly. Um, Speaking of emerging technologies, leaving optical to the side for now, we do have a question from our audience about direct-to-device satellite connectivity from companies like Link and AST, Space Mobile, and Starlink. Um, they're asking, what opportunities do you see there as terminal manufacturers? So does that present opportunity for terminal manufacturers, or is that more of a threat? That's me adding my own 2 cents, but what do you guys think?
I
I'm
think
gonna go
it's
back. Oh, go ahead, Lucas.
I think there's it's more of a complementary service, because these are very different things. If you do direct to device, you'll have texting capabilities, or maybe very low speed IoT type of data rates. So if you want to do streaming or broadband of any kind, as far basically you need to go up in size. The other way around is if you try to use very sophisticated VOD codes, where you can go down in the all the way down in the noise floor and still get data rates through. But the technology is not really mature. So as of now, those are complements. It's not the same thing. At least not to us.
Yeah, and Lucas, I have to agree with that. A lot of the it, a lot of the discussions come from a hype, a shiny object coming out, and people focusing on it. But in satellite communications, there are tools in the toolbox, and every tool has a purpose. I don't use a hammer to put in a screw. I go get a screwdriver, right? We're all doing complementary offerings to the end service, either whether it be price, whether it be quality of terminal, whether it be function, whether it be purpose, right? And those things just have to, in this environment where things are expanding so fast, and it's almost like we're taking into our cell phone technologies and comparing it to a satellite terminal technology. They're both they're complements of each other, but they're not doing the same functional purpose in the end. And so that's one thing that these have driven is new technologies, but at the same time, sometimes you need large gateways to do things for geos. You need smaller gateways to do things for LEOs. You need medium size for MEOs. You need things that can track in different ways. And so all of them are just, complementary tools in a toolbox that you keep there to get done what you need to get done.
Yeah, I might add, AS&T Space Mobile is sort of the outlier there. They're the ones that claim they can do LTE type data rates direct to handset or direct to device. All the others, I agree, are very much. Even in the Apple case, I wouldn't even say text messaging. It's canned text emergency messages. So the data you're actually sending back, is very minimal, maybe just a single character. But AS&T Space Mobile is they've just deployed the largest phased array in space, and their production satellites will be even bigger. But I think what remains to be seen in that situation is how expensive is it on the satellite in terms of satellite resources to be able to do that, and how many users are they going to be able to address in a given geographic area or spot beam of coverage. I think that still needs to be proven. I think they've shown they can deploy the array. They deployed it successfully, but I think there's still a lot of challenges there that need to be overcome. But from a perspective of like Lucas was saying, very different things as far as high data rate, mobile comms. On the OneWeb network, we're pulling down 120-ish, 140-ish megabits per second. Doing that direct to device, I think we're just talking about very different things.
Yeah, I think the other panelists have summed that up quite nicely, so nothing to add from me on that.
All right. Well, I think out of respect for time, we will call it here. I want to give thanks to all of our panelists for participating in this webinar and having a really lively discussion. For those that did submit questions that there was not time to address during the webinar, they will be shared with our panelists in writing so that they can get back to you. We have a handful that remained. And the webinar will also be posted online, I believe, tomorrow. So keep an eye out for that. You can share this with others if you found it interesting. Round of applause for everybody. Thank you so much for your time.